as a question, or are you just adjusting your glasses? What? Math homework due tomorrow? Sounds about right. So what was the question? The what? I think you're right. I think what's tomorrow, the 27th. So I think I made the homework due the 28th, like 10 at night or something. But yeah. So if there's a particular problem that you're curious about, you can ask. It's in my math lab, so in Pearson. Mm-hmm. And the give me just a second here. I'll bring it up. Let's see here. So this is how it looks for me, of course. So I see 15 of you are enrolled, which means there are still 10 who have not enrolled in the my math lab, which is unwise. I can't make you do it, but let's see here. Oh, come on. Really? Well, let's try again. I've opened it here before. It's weird. I think computer work is like the definition of insanity, right? What did I do? I just did exactly the same thing again, and that works. So try again, I guess. Let's see here. So basically the chapter 1 homework is due Saturday. So 1.1, 1.3, 1.4, 1.5, 1.6. So the 1.6 problems, for example, like find the distance between these points on the number line. That's what we talked about at the end of class, right? We take the absolute value of the difference, so like absolute value of minus 49, minus 2, you know? What would the answer be? What's minus 49 minus a minus 2? It's minus 47, and then you take the absolute value, so you got 47. Let's see if it works. Check answer. Ooh, look, positive affirmation. Nice work. I feel smarter now. All right, the question is complete. Okay, great. Whatever. And so it goes. So there's a bunch of questions in 1.6 about distance. So we're going to solve absolute value problems, right? So we're going to do those today. And eventually, in the later parts here, we'll eventually get to problems that are like solve an inequality involving absolute value. That's what we're going to talk about today. If you go back to the go back. Leave. Yes, I'm leaving. So the section 1.1, 1.3, 1.4, what were those? These are these kind of problems, right? Solve 3x equals to 18. We did those like the second class meeting, right? Last Thursday. So again, is there a particular problem you guys are stuck on, or? I've got it open so I can look if there's one. All right, well, I'm going to start into the section 1.6 material then. Close this down. So everyone clear on how to start this? You have to get the access code. You have to, I have a link on the announcements where you get started, but you need the course ID, which I posted an announcement, which was what? I heard Cook 7090. Yeah, let's see here. If I go back far enough, I'll see it again. Let's see here. Yeah, Cook 70930, right? Which is also posted in course announcements. That's the course ID. You need the access code in order to get access to the access code. Costs money. How much did it cost through the website? Anybody buy it through the website? Just for this course? Is it 104? It's through the website or through the bookstore? What's that? Through the website. Now, was that just for this course alone, or is it like for year access, or? Wasn't sure. I know sometimes like Pearson sells like some kind of like universal access for a bunch of courses, but that, I don't know. There's, like I said, a lot of different purchase options. I'm certainly not aware of all of them. Let's see here. Who just came in after I was done calling names? Me. Name? Richardson? Okay, cool. Gotcha. All right. So let's talk more about how to work with absolute value. Come on. Go back to your home. Seriously, come on. You can do it. You can do it. Okay. So equations and inequalities involving absolute value, right? So this is section 1.6 in the text. And remember, you can read the text as an ebook in the My Math Lab once you get in there. So what was the definition of absolute value? You guys remember? Absolute value of x is equal to what? It's equal to x, or, well, yeah, x if x is greater than or equal to 0, and it's minus x if x is less than 0, right? Now, if you just want kind of a quick statement of that, you could say what? AKA absolute value of x is plus or minus x, right? And the plus and the minus, which one you do plus, which one you do minus, depends on whether x is positive or negative, right? But absolute value of x is plus or minus x. Them's your choices, right? So, and we had some properties last time. What were the properties? Absolute value of x greater than or equal to 0, right? The absolute value of, let's say, a times b is absolute value of a times absolute value of b. Those are the big ones. There's more, but the other thing is absolute value eats minuses, right? So like the absolute value of, say, minus a is equal to the absolute value of a. These are properties of absolute value we should keep in mind. And we're also going to be talking about solutions today and solution sets. Solution sets for inequalities, solutions for just equations, right? So let's get to work on our examples here. Example 1, how about this? If we're going to solve the absolute value of x equals to 3, how do you do that? Let's see here. So this means that plus or minus x, right, is equal to 3. So what does that tell you? So that implies that x is equal to plus or minus 3. So that's the first principle. Here's a principle of calculation. All right. If you have absolute value of stuff equals to blah, all right, how do you solve that? Well, then you can look at that as stuff equals to plus or minus blah, and you can solve that, or you could put the plus or minus on the other side. You got choices. You could put plus or minus either on the right or the left. It's logically the same. Now putting the plus or minus on the right makes it like really easier in this case, right? Because if I put the plus or minus on the right, I look at it and I go, oh, so that's the answer, right? The solution here, x equals to minus 3 or x equals to 3, which we can express that either as that sentence, right? Or we could just the thing above, which is x is plus or minus 3, right? What if we were going to solve, say, absolute value of x is equal to minus 2? Solve that. The instructions for all my examples today are pretty much solve, right? So, what's the solution set here? Can you have absolute value of some quantity equal to negative 2? Right? We cannot do that because that's one of the fundamental things about absolute value is it's non-negative, right? So this is impossible. So solution set is just the empty set, right? No solution. No solution exists. As a point of sort of annoying wordplay, that is the solution. I mean, to this problem, the solution is that there does not exist a number that you can plug in and make it work, right? That is the answer to this problem. So, example 3. How about this? Absolute value of 3x minus 7 equals to 22. So to solve that, we go, aha. This means that 3x minus 7 is equal to plus or minus 22. So then I do what? I try to solve for x like we did before, right? And so this gives me 3x is equal to 7 plus or minus 22. Right? Add 7 to both sides. And then what? Divide by 3. Very good. So we get x is equal to 7 plus or minus 22 divided by 3. So what does that mean? X is equal to 7 plus 22 over 3, or x is equal to 7 minus 22 over 3, right? So to simplify that, that's what? X is equal to 29 thirds, or x is equal to minus 15 thirds, right? Which I guess we could simplify, right? That's minus 5. there is almost never a need to simplify an improper fraction in here. Leave it improper. I would like to see 29/3. Please do not write 7 2/3. For one thing, it's wrong. For another thing, let's see here. 29/3 is what? 9 2/3. But let's not write that, right? Let's leave it as 29/3. Any questions so far? Now, we're working with this plus minus notation. It's kind of, it's okay, but you gotta, it gets a little bit tricky once you have minuses and stuff involved. So another strategy we can use is just to break it into two problems and solve the two problems separately. All right, that's definitely something we're going to want to do when inequalities are in play. So let's start doing it now. Let's forego the plus or minus notation and just break it into cases. So how about, here's one. Solve. Absolute value of 3 minus x is equal to 2 plus x. So there's two cases to consider here, right? So case 1, we're going to solve 3 minus x is equal to 2 plus x. All right, and I'll put them side by side. Case 2 is 3 minus x equals to minus parentheses 2 plus x. See, because the absolute value either works out to plus or to minus. So case 1, what do we want to do? How about add x to both sides? Subtract 2 from both sides? What do you get? I get 3 is equal to 2 plus 2x to start with, right? Which then tells me that 1 is equal to 2x, right? Subtract 2 to the other side, I get 1 equals to 2x. Then what do I do? Divide by 2, that's right. So x is equal to a half. That's one of the solutions, right? How about the other side, though? What goes on over there? Well, I think a starting move I'm going to make here is to distribute that minus, right? That's minus 2 minus x. Careful about that. That's a common place to make a mistake, is when you have a negative not distributing it through. Yeah? And, oh, well, that's kind of funky. Oh, that's perverse. Like, that's so weird. Look at that. So I got minus x on both sides. I add x to both sides. What happens? They cancel. What do you got? You got 3 equals to minus 2. Also known as 5 equals to 0, right? Or 1 equals to 0, whatever you want it to be. But, yeah, that's not a good sign. I mean, it is a good sign. It means that there's no solution here, right? So if we make legitimate algebraic steps and come to an absurdity, then we can rightly conclude there was no solution in that case. Interesting. So it's possible to have one of these kind of equations come out to just one answer, or no answers, or 2 answers. Those are at least 3 possibilities we've seen here so far. Trying to think why this is the case. Oh, I think I can explain this graphically. Now I'm jumping ahead to a future chapter. You don't have any homework on this or anything, but if you're curious what's going on here, let me show you. So, and if you don't care about this right now, you don't have to, but here's a look at it. So y equals to, this is equal to 3 minus x, right? Because absolute value eats minuses. So we could look at the left-hand side of this as y equals to absolute value of x minus 3. Of course, y equals to x plus, 2 plus x, well, that's a line, right? Let me use some color coding here. Y equals to 2 plus x is a line. So if you graph both of these, which I think we'll eventually do in here, I could be wrong about that, though. I lose track of what's in 100 and what's in 113 off the top of my head. Haven't been here long enough. So this absolute value of x minus 3, it's a v, which just sort of like is based at 3. When you plug in 0 into this, you get it intercepts at 3 as well. Y-intercept of this is 3. Plug in 0, you get absolute value 3, which is 3. So this is the graph of the absolute value. The graph of that line is what? It's a line with slope 1. It has y-intercept 2. So that line is like here, and so it's got slope 1. It looks something like this. And these are parallel lines, because they both have slope 1. So these two guys never intersect again, and the sole point of interception, the sole point where both of these expressions have the same output, is the place where the graphs cross. It's the point of intersection. So that's why there's just this one point here, which we found is at a half, right? In contrast, this first problem, absolute value of x looks like this. And if you look at the intersection of y equals absolute value of x with y equals 3 is a horizontal line. So there's 2 points of intersection, 3 and minus 3. That's why we found plus or minus 3 there. There were 2 points of interception if you want to take a graphical perspective. All right. Now, this is just bonus at the moment. I'm not going to test you on the graphical thing I just said, right? Not yet, anyway. Once we get to that in the homework, then we'll talk about it, but more completely. But just for now, I just wanted to give you kind of a, hey, sidebar, that's why this is happening to us. All right. Any questions? How many of you guys are already comfortable with graphing a line? Like, kind of, sort of is okay, right? So that is something we'll come back and do in here once we get to that part of the book, all right? So if you don't already know it, it's okay. We're going to review how to graph lines in here eventually. I could take the mystery out of it and tell you. I just have to look in the table of contents. Ah! Curses. This book is not helping me. Well, yes, chapter 2 is graphs of equations. So, like, next chapter we're doing this stuff, right? So I'm not that far ahead. Let's do another. How about try to solve the absolute value 7x plus 10 is equal to 3 minus x. All right. So we got 2 cases. We have 2 cases to consider, right? We've got to think about 7x plus 10 equal to 3 minus x, right? And what's the second case? So this was the plus, right? This is the minus. I'm going to go, I don't know. So the plus, the minus. All right, so 7x plus 10 is equal to minus, parentheses, 3 minus x. So what we got? We have add x to both sides. We get what? We get 8x is equal to 3 minus 10. So I added x to both sides, and I subtracted 10 from both sides. So the 10 cancels, and the x with the minus x cancels, right? We get to that. Then, well, because the 3 minus 10 is what? Minus 7, right? So what's the solution here on this side? We got x equals 2 minus 7 divided by 8. There you go. So that's one solution. How about the other side? I would advise distributing that minus, right? So this is going to give us a minus 3 minus a minus x is plus x. Now what should we do? You want to isolate x, right? So what should we do? If we subtract x from both sides and we subtract 10 from both sides, what do we get? We get 6x is equal to minus 3 minus 10, also known as minus 13. Are you guys following me? I know I did two things at once, right? I subtracted and I did the x part and the number part in one step. The next example, I can write all the steps out if you're losing me. So then what? We got what? X equals 2 minus 13 over 6. So there you go. This is the answer. We have x equals to minus 7/8 and x equals to minus 13 over 6. There are two answers. Let's do another. What if we had like absolute value of 3p minus 2 is equal to 3 plus 2p? The same song and dance, right? Just instead of having an x, I've got a p. But don't be, don't be scared by that. It's the same steps. We solve 3p minus 2 equals to 3 plus 2p. Or we solve 3p minus 2 equal to minus parentheses 3 plus 2p. So I'll work on the number 1 first. I will subtract 2p from both sides. That will give me p minus 2 is equal to 3. And then I will add 2 to both sides. Right? And that will give me p is equal to 5. That's one possibility. What's the other? So I distribute the minus. I've got my minus 3 minus 2p, right? Let's add 2p to both sides, right? That gives me 5p minus 2 is equal to minus 3. All right, so I'm trying to isolate the p, right? So next I add 2 to both sides to get rid of the minus 2, right? So that gives me 5p is equal to minus 1. What is the finishing blow here? Divide by 5. That's right. You got it. P equals to minus 1 over 5. Cool. I could not, if I was to have to design a problem where a number and its reciprocal up to a sign are the answers, like I would have had to work at that. Like the fact that the answer turned out to be 5 and minus a fifth, that's just funny to me. I don't know. These things always amuse me more than the students, but anyway. All right. Do you guys feel like you could solve equations involving absolute value? I think that's a pretty good set of examples. Now you need to go work some for yourself, right? Next up, absolute value. All right, so absolute value, little bit trickier. Now I'm going to remind you that the problem of absolute value, really, we can think about in terms of distance on the number line, right? Just making sure my camera's not wandered. So, reminder, right? The absolute value of x is equal to the distance of x from 0 on number line, right? Or we can also look at this, the absolute value of b minus a is equal to the distance from a to b, right? Just let's keep that as a backdrop. So, example 7 for today. I want us to solve the absolute value of x less than 3. Give answer in interval notation. Remember that interval notation we started with the other class? So that again. So what's this look like? Right? Here's origin. And this means the distance from the origin is at most what? 3, right? So what points does that, I mean, certainly 2 is in there, right? How about minus 2? Is minus 2 in there? Is minus 2 less than 3 units of distance from the origin on the number line? It is, right? It's 2 units to the left. How about minus 2.99? Is that less than 3 units of distance from the origin? Sure enough, right? And the same on the other side. So think about it. What's the answer? You're going to go from minus 3 over to 3, right? This whole open interval should be the answer. So the solution minus 3 to 3. What kind of solution did I just use? I would say this is not an algebraic solution. What I just gave you is a geometric solution. I gave you the solution in terms of a picture. This is not always the best way to do things, right? What's the algebraic approach here? How do we unfold absolute value of x? Algebraic. Algebraically, absolute value of x less than 3, it gives you 2 different things, right? This means that either x is less than 3 or minus x is less than 3. Up to this point, I've been very sort of, nonchalant about whether the plus or minus goes on the left-hand side or the right-hand side. I can't do that now. Inequalities are in play. If I multiply by minus, flippity-floppity, right? I mean, so I got to put the minus where the absolute value is, right? Then what? Well, x less than 3 Great. Done. Can't simplify that anymore. How about this, though? How do we simplify this inequality? How about multiply by -1, right? So x is greater than -3. Because when I multiply by -1, the inequality has to flip. So we have x is less than 3, right? Or we also have x is greater than -3. So I need one of those conditions or the other. I actually need them both. Right? I mean, clearly, like, if I put x equals to 4, that's not a solution, right? Is absolute value of 4 less than 3? No, right? So I actually need this and that. Now, what do you get if you have x less than -3 and x greater than -3? What is that? We can write it like this, right? -3 less than x less than 3. We can put those together. And of course, the set of x which solve that inequality is the open interval from -3 to 3. Right? So let me put a principle here. To solve absolute value of, I need let's say Pac-Man is less than a number, let me call it C, all right? So if you're solving the absolute value of some expression, which I've called Pac-Man less than C, what you can do is, it's the same as saying that the Pac-Man is less than C and minus Pac-Man is less than C. So you need to solve both of those. It's an and. Let me be less cartoonish and give you another example, which isn't quite so simple. So what if we were going to solve, I don't know, absolute value of 3x minus 8 is less than 10. So what I'm telling you is that this can be exchanged for the following. Minus 10 is less than 3x minus 8 is less than 10. Yeah, let me I mean, this is not wrong, but it's also not helpful. Let me fix this. All right? Minus Pac-Man less than C, we can rewrite as what? We could rewrite that as Pac-Man greater than minus C, right? So you can put Pac-Man in the middle. You've got minus C less than Pac-Man less than C. So you can rewrite a inequality, less than inequality with absolute value, as a compound inequality without the absolute value. That's the theorem. So like here, absolute value of 3x minus 8 less than 10 means that minus 10 is less than that is less than 10. Again, like the underlying idea is that this, whatever this is, it's like distance 10 from the origin on the number line. So that means it's between plus or minus 10 from 0. I mean, wherever that is, it has to fit between minus 10 and 10. Anyway, so now we have this. What can you do? How about add 8 across it, right? If we add 8 across the inequality, what do we get? Minus 2 less than 3x less than 18 right? And then what do I do? Divide by 3. We have a winner. Very good. So minus 2/3 is less than x. Is less than, well, 18 over 3 is 6, right? So that's the solution. What's the solution set in interval notation? We do what? Open interval minus 2/3 to 6. Let's do another. Example 9. But first, are there any questions? You can still ask your question in the middle of this example. I'll go on here. So if I had absolute value of, say, 10 minus 4x is less than 6, all right, then I'm going to trade that for the compound inequality minus 6 less than 10 minus 4x less than 6. Now what should I do? I guess I can subtract 10 across the inequality, right? I can isolate the x term like that, right? Minus 10, minus 10, minus 10. That gives me minus 16 less than minus 4x less than minus 4. Now what do I want to do? I want to isolate x, right? Divide by 4. But I got a minus 4. So, I mean, right idea. Let's just make it a minus 4, right? Divide by minus 4. What is that? I'm dividing an inequality by minus 4. What do I have to do? I have minus 16 over minus 4, right? Minus 4x over minus 4. Minus 4 over minus 4. So many minus 4s. But I had before less than and less than. But I have to, yeah, greater than and greater than, right? Which, of course, is what? This is 4 less than x. Assuming greater than x, greater than 1. Now, I don't know about you, but I have trouble reading sentences with greater than. I just default to less than, you know? So, like, just take this and write it the other way. 1 less than x less than 4, right? That's the same inequality, but expressed with less than rather than greater than. It's more natural because we read number lines left to right, right? You read your comic books like left to right, right? I mean, unless you like Japanese comic books, then they're kind of like every different which way. Right to left, right. Exactly. So this is kind of like a manga style inequality, whereas this is, you know, Marvel. I don't know. I really never read comic books. All of my comic book knowledge comes from my friends. So. Oh, anyway, so what's the open interval? So this says the solution set is 1 to 4, right? So the solution to this inequality is 1 to 4. Are we good? So just flash forward, just a flash forward. Comment from the future. if you look at the graph, y equals the absolute value of something like ax plus b. So if you have y equals absolute value of ax plus b, what that looks like is just a v. Essentially, the graph is just some kind of v. It doesn't have to have slope 1. Somewhere there's an x-intercept, right? And if you're looking to solve the inequality, absolute value of this less than c, what are you doing? Well, y equals to c is like this, perhaps, right? So it makes sense that the solution we're finding, it's just an open interval, or if we put equality, it's a closed interval, because it's only like this part, right, of the graph of absolute value, which is actually under that line, y equals to c. So graphically, that's like why we're finding this, if you want to think about it in terms of, you know, the outputs of an absolute value function. You could think this way in Chapter 2 thinking. What would happen if instead of doing less than, we did greater than? Right? What if I asked you for what points on this graph is the absolute value of like ax plus b greater than c? Well, if you think about it, right, you see that there's two different things, right? It's like up here or up here, right? So it would be kind of like this or kind of like that. That would be the solution set to greater than c, if you want to think graphically for a second. It looks like there's going to be something very different about greater than problems as opposed to less than problems. There is an asymmetry in how we solve these. Beware. Know your enemy. Let's see here. What am I saying? Math is your friend. All right, so example 10, I'll kind of do the same thing. How about we have absolute value of x greater than or equal to 3? I'll give you a graphical solution to start with. Look at a number line. Here's your 0, right? And here is 3. Here is minus 3. Where can x be? It has to be more than 3 units away from the origin. You have two choices, right? Two logically disjoint choices. You can either be over here, or you could be over here. So there are two disjoint cases. And the solution, just looking at the number line, is minus infinity to minus 3. Oh, I threw equality in, so I got to put square bracket. Union with 3 to infinity. How would I come to that understanding? If I didn't want to always draw number lines and think through number lines, how would I come to that understanding algebraically? If we have absolute value of x greater than or equal to 3, right? There are two different cases, right? Either you've got x greater than or equal to 3, or you've got minus x greater than or equal to 3. So x greater than or equal to 3, lovely, we already have that, it's right here, right? That's these guys. But how about this? Divide by minus 1, we get x less than or equal to minus 3. Those are these up here, right? That's like that kind of x. These are disjoint cases. You can't have both at the same time, right? So the answer for an inequality of this form, which involves greater than or equal to, it's going to be a union of 2 raised to infinity. All right? Any questions? Well, let's work on an example, right? Let's see here. What if we absolute value of 17x plus 3 greater than 2? So what do we face here? We face 17x plus 3 greater than 2, or minus parentheses 17x plus 3, close parentheses, greater than 2. So we have to solve these inequalities separately, yeah? This one, I'll simplify. This is minus 17x minus 3 greater than 2. All right, so how about the first one? We subtract 3, right? That gives us 17x greater than minus 1. On the other side, I'll add 3. And I get minus 17x greater than 5. So let's see here. The left calculation, I do what? I just divide by 17, right? That doesn't flip the inequality. It just gives us x is greater than minus 1 over 17. Okay, that's as simple as it gets. That would indicate the solution set, what? Minus 17, minus 1 over 17, right? To infinity. That's x that are like that. X to the right of minus 1/17. Now on the other one, I got to divide by minus 17. That does what? Less than minus 5 over 17, right? So that means that x is to the left of minus 5/17 on the number line. So I go minus infinity to minus 5/17. You notice what I had to use in the previous example? I had to use this union, right? Union. Same here. So the answer? Solution is minus infinity to minus 5/17 unioned with minus 1/17 to infinity. Any questions? Let me leaf through your book here for a second, see if I can find any other problem types I'm missing. See, there's some simplification problems that I haven't solved. There's one I didn't do yet. Okay. I'll throw in a few more examples. So at this point, I'm just going to kind of go back to the start of the lecture and supplement a couple more examples about equality. Let's see here. So one I noticed in the homework it looks a little bit different than what we've looked at was, absolute value of 2x minus 1 over 3 equals to 5. And there's also like inequalities that are kind of like this. Someone try to hit one of those after this, and I think that'll probably be it for today. How do you solve this? What do you do? Multiply both sides by 3. I like that a lot. So multiply by 3. So that gives us the absolute value of 3 times 2x minus 1 over 3 equals to 15, right? Now here's the thing, is you can bring the 3 inside because 3 is positive. All right. And then you cancel the 3's. We've got absolute value of 2x minus 1 equals to 15. So we can either do our 2 cases or we could do the plus minus. It's kind of up to you guys. I'll do the 2 cases. So we have 2x minus 1 equals to 15, or 2x minus 1 equal to minus 15. You have freedom in the equality case. You could put the plus or minus on either side. Again, with the absolute value, you got to be careful. It has to go on where the absolute value is for the inequality problems. Anyway, so we get 2x equal to 16, and 2x equals to minus 14. Divide by 2. We got what? We got x equal to 8, and x equal to negative 7. Right, so these appear different at first glance, but it's really the same kind of problem that we worked earlier. Oh, I just found another one. Well, I don't know if I've assigned any of these, but just in case I have, let me throw one in. What if you have absolute value of x plus 3 equal to absolute value of x minus 6? What would you do here? So, okay, so what I would say is I'd say, okay, so this means that either x plus 3 is equal to x minus 6, or x plus 3 is equal to minus x minus 6. I mean, either they can match in sign or they differ by sign. Logically, that's all that can happen. They either have to like match up or be negatives of each other. You sort through things. And so, of course, this gives us 3 equals to minus 6. Oops. So that, nothing there, right? But the other one gives you 2x equals to 9. Well, no, 6 minus is plus, so 6 minus 3. So we get 2x equals to 3, x equals to 3 halves. Aha, so there we go. So that's that one. Now our final example for today is problem 103 from section 1.6, basically. And it is 7 minus the absolute value of 3 minus 2x is greater than or equal to 5. How are we gonna deal with something like this? Subtract the 7, right? So that gives us minus absolute value of 3 minus 2x is greater than or equal to minus 2. Now what are we going to do? Like, oh man, this is one of those greater than or equal to problems.